Here we are discussing spherical and cylindrical waves. So first I am talking about spherical waves. First one is spherical waves. For the spherical wave, generally, just if we discuss about generally, in general condition I'm talking on this. So longitudinal and transversal waves. So longitudinal and transversal waves. So longitudinal and transversal waves, so they can travel in a single direction. They can travel, so they travel in a single direction. So this is in a single direction. This is about this longitudinal and transversal waves. So just you consider, okay? So consider, now I'm taking about a point source. This is what a source is, the source of it's a sound, okay, propagated in all the directions. So this is, it consists of concentric circles, okay. This is that propagation of the sound, okay, in all the directions, okay. So now here we can take about is the propagation of sound in all directions. From here, this three-dimensional spherical region, which is what this, what is a three-dimensional spherical region, three-dimensional spherical region, okay, is called wave front. It's a wave front, okay. So now this is the wave front. The wave front can travel, which is equal to the speed of sound. Now we can say wave front. So wave front of sound, wave front of sound can travel. It can travel. So with a speed of sound, okay. So this is what 332 meter per second or 333 meter per second, like we can consider on this. So next one. Now the waves emitted by the point source are spherical waves. So which are waves emitted. So the waves emitted by a point source, so are spherical. They are spherical, okay, spherical waves. So spherical waves, and they are, then what you say, they are concentric circles, okay. So for example, this is the point source. Now the waves which can be propagating, like they all of having this same center, so different radii, so they can be propagating in all the directions like this, okay. So now my question is about how do you find the intensity of this source, okay. Intensity is equals to I is equals to what? Power per surface area. You know surface area 4 pi r square, okay. So I is equals to P by 4 pi r square. From here we can say I is proportional to 1 by r square, okay. So I is proportional to 1 by r square. I means what? Amplitude square is proportional to 1 by r square. Amplitude is proportional to 1 by r, okay. So this is A is equals to A naught by r, we can say on this. This is what? Amplitude. It's a amplitude. So is the maximum one. Now we can write its equation. The equation of the wave y is equals to, okay, A naught by r is the maximum amplitude, okay. This is what amplitude of the wave. So it's what? Sine omega t minus kx is the displacement equation for spherical wave. Now cylindrical waves, line sources can emit cylindrical waves. cylindrical waves, like a tube light. Okay. Now I'm talking, there is about, this is what, it's a line source. Okay. So here we can take on this. It's a cylindrical. Wave fronts can be formed. The wave fronts can be formed like this. Yes, it can be propagating in all the directions, like so. These wave fronts can travel, which is equal to speed of sound. So now its equation, y is equals to a sine omega t minus kx. Okay. Now I want to know, I want to write its equation. What is the amplitude is my question. So for this, first one is intensity. Intensity I is equals to power per surface area. What is surface area of this is what, 2 pi RL. Okay, 2 pi RL. This is what its length is this. So I is equals to P by 2 pi RL. I is proportional to 1 by R. So I means what? Amplitude square is proportional to 1 by R. Amplitude proportional to 1 by under root R. Now this equation can be written as here y is equals to, okay, y is equals to, this is what, a naught by root R sine omega t minus kx is the equation for displacement for the which one, cylindrical waves.